We're going to review two-step equations. So again, we're just following these 4 steps on the screen right now. There's LCO, so if you ever see a problem that's subtracting something, you can change it to an addition and then just take the opposite of the number behind it. Subtract the constant. Again, remember, constant is the number without a variable with it, so the one that's all by itself. Divide the coefficient. Again, the word coefficient is the number in front of your variable. So if you have 3x, 3 is the coefficient because it's the number in front of x. And then finally, you're checking your solution. You're replacing the variable with your solution. I've simplified these steps for you that you can just follow them every time, but in the end, we are just using inverse operations. So if you see something that is adding, to get rid of it, you want to use subtraction. If you see subtraction and you want to get rid of it, go to adding. If you see that 2 things are being multiplied and you want to get rid of it, go ahead and divide it. If you see that 2 things are dividing and you want to get rid of it, you just multiply it. So I have this equation, 5x plus 6 is equal to 41. Again, my goal is to get x by itself. So I can go ahead and just start doing these 4 steps that I have up here. Step number 1 says to use LCO. However, I'm not subtracting anything here, so I'm allowed to skip that step. Step 2 says to subtract the constant. My constant in this case is the 6. I am subtracting because you can see that I am adding 6 to the 5x. So to get rid of it, I must subtract 6 from both sides. 41 minus 6 gives you 35. Step 3 says I need to divide by the coefficient. The main reason why I'm dividing by the coefficient is because here I have 5x, or 5 times x. The inverse operation of multiplication is division, so I'm going to divide both sides by 5. 35 divided by 5 is equal to 7. However, I need to make sure that that is the correct answer. So I'm going to take my variable and replace it with 7. So up here I have 5x plus 6 is equal to 41. Again, I'm just going to replace this x with a 7. You can just plug this part right here into your calculator. 5 times 7 is 35, plus 6 is 41. 7 is the correct answer. Following those 4 steps and using inverse operations to solve this problem. Step number 1 said to use LCO. I am subtracting 3x, so I'm going to go ahead and change that to plus negative 3x. Step 2 says to subtract the constant. My constant here is negative 8, so I'm going to go ahead and subtract negative 8 from both sides. That's going to cancel the negative 8 from the left side, leaving me with negative 3x. 25 minus negative 8. Again, I could use LCO again here to have 25 plus 8, which will give me 33. Step 3 says to divide by the coefficient. So I'll divide both sides by negative 3 to cancel out the negative 3 in front of the x. Because again, negative 3x means negative 3 times x. The inverse operation of multiplication is division. 33 divided by negative 3 is negative 11. At the moment, I think that my solution is negative 11. I can check my solution by taking my solution here and substituting it in for x in the original problem. The original problem was negative 8 minus 3x is equal to 25. Again, as I'm saying, I'm substituting it, so I'm just going to replace the x with negative 11. You can easily, again, just plug this part into your calculator. However, I know that negative 3 times negative 11 is positive 33, plus negative 8 is 25. Negative 11 is the correct solution. For this next problem here, those 4 steps are going to have to be moved around a little bit and revised. Again, I don't need to use LCO here. I'm not subtracting anything. To get t by itself, I'm seeing that I'm adding 9. I want to get rid of that first because I'm adding 9. I will just subtract that constant. Again, adding and subtracting are inverse operations. These two cancel each other out. I'm left with t over 5 is equal to negative 9 minus 2, or negative 11. Now, originally, the steps say that I need to divide by the coefficient. However, here, I have t over 5, or t divided by 5. The inverse operation of division is multiplication, so to get rid of that 5, I'm going to multiply both sides by 5. Negative 11 times 5 is negative 55. I do need to make sure that I'm checking my solution. The original problem was t over 5 plus 9 is equal to negative 2. I'm going to take my solution here and replace it for my variable there. So I'm going to replace the t with negative 55. Negative 55 divided by 5 is negative 11, plus 9 gives me negative 2. This is the correct solution. For the final problem, I see that the whole thing is a fraction. However, as I stated in the previous problem, this fraction bar is really just a division sign. So if I want to get rid of the 6, I can just multiply both sides by 6, and that would cancel out the denominator, leaving me with the numerator. Negative 1 times 6 is negative 6. I still need to get w by itself. There are 2 different ways that you can do this. You can go ahead and say, hey, let's do LCO, giving me w plus negative 3. And then you can go ahead and just subtract your constant. Or, looking back at the original problem, if I have w minus 3 is equal to negative 6, I can just go ahead and use inverse operations. The inverse to subtraction is addition. I can just add 3 to both sides. You get the same answer no matter what. Negative 6 minus negative 3 is negative 3. I do need to make sure I check my solution. I'm going to take the original problem up here and substitute negative 3 in for w. The original problem was w minus 3 over 6 is equal to negative 1. Again, I'm replacing the w with negative 3. Negative 3 minus 3 is negative 6. Divided by 6 does give you negative 1.